Tangent is so real.
Okay.
Yeah.
Note card. But I have to qualify this a little bit. And so write these three down, and then I'll write the next things down, and you'll say, well, why did we write the first three down? Because, yeah. So, yeah, I'll explain why we did what we did.
Oh, wow.
Can you see this good enough? There. Now you can see it good enough. These are inverse trig functions.
I don't remember the last time I laughed that hard. This video wasn't.
Yeah, that was something.
Oh yeah, Taylor was like, what is up?
Hey, are you going to find your note card sometime here?
What do you think I'm doing? This is really not care what you do. No, he came up and I thought he was going to yell at me, and I was watching TikTok, and he actually just asked me about gymnastics. I don't know where it is.
Okay, well, it is what it is.
I'm seriously trying.
Yes.
And I'm really hungry.
Now, there's also the inverse of secant, cosecant, and cotangent, but I've never seen those three on the test. That's more of a BC Calc thing than an AB Calc. And so you guys are AP Calc AB, not BC. Because AP Calc BC covers two more chapters, two more units, not units 9 and 10. And they also have some stuff thrown in there from the other units. Okay, good. All right, so the first derivative of the inverse sine of x is 1 over the square root of 1 minus x squared. And when you watch the videos today, he will show you why that is. I'm not going to explain all that because the videos are great. He does a great job of explaining it. Now, what I want you to also write down is the first derivative of the inverse sine of f of x equals 1 over the square root of 1 minus f of x squared times the first derivative of f of x. So if you have more than just an x there, that's what we're saying. So cosine would just be the negative of that. And tangent would be basically, if we multiply by the first derivative, the numerator becomes the first derivative, right? So I can just rewrite it like this. Okay, so let's look at some examples. If we take the arctangent of negative 5x, we know the arctangent of x is the same as the inverse of the inverse tangent of x. Okay? So the inverse tangent of x was 1 over 1 plus x squared. Well, this isn't just x, that's basically our f of x. So the first derivative of negative 5x is what? No, negative 5. Over 1 plus negative 5x squared. Correct? The first derivative of this times this squared. Well, that would equal choice C. We're good with that? Okay. So let's do it if there was a 2x. So it'd be the first derivative of 2x, which would be 2 over 1 plus 2x squared, which would be 4x squared. Now they say evaluate it if x equals negative 2. So it'd be 2 over 1 plus 4 times negative 2 squared is 4. So it'd be 2/17. Good with that? So let's do the arc cosine of that. Okay? Arc cosine is negative 1 over the square root of 1 minus x squared, correct? Okay? And so, since we have an f of x here, we have to take the first derivative of this. This is really negative 1/5 x, right? So what's the first derivative of negative 1/5 x? Negative 1/5 over the square root of 1 minus negative x over 5 quantity squared. Everybody following yet? Okay, you get that off your note card. Okay, so if you square this out, well, you square this out. Let's leave it the way it is for right now. It'd be 1 minus x squared over 25 times a negative 1/5. Now, they say evaluate that at 2. What's 2 squared? 4. 1 is the same as what over 25? 25 over 25 minus 4 over 25 is 21 over 25, right? So we have negative 1 over the square root of 21/25 times a negative 1/5. Well, 21/25 is the square root of 21 over 5 times negative 1/5. This 5 down here is like 5 over 1, right? So these two 5s do what? Cancel. So I get a positive 1 over the square root of 21. And in Khan Academy, you don't have to rationalize the denominator. If you did, they'll still count it right. So that's what I would say as an answer. Khan Academy lets you have this as an answer as well. Okay? So that's inverse trig functions. Can you handle that? Just plug them into the formula and working through the numbers. Okay. Then, figuring out where people make mistakes. Olga tried to find the derivative of sine x times the square root of x. What process do you think she should use? The product rule, because there's two things multiplied together. So she said, yep, I'm going to use the product rule. The product of sine times the product of the square root of x. So you take the derivative. When you do this, you take the derivative of the sine of x times the square root of x plus the sine of x times the derivative of the square root of x. Okay? Which, that's correct, right? Step 2 is correct. Step 3, she says the derivative of sine is negative cosine and the derivative of square root of x is 1 over 2 square root of x. That's correct, right? No. She made a mistake right there. She made a mistake on step 3. She didn't differentiate sine correctly. So you'll have problems like that. Let's look at another one. Rhea tried to find the derivative of the cosine of x over x squared minus 6. What should you do? Quotient rule. Yeah. So she decided, hey, we're going to use the quotient rule. Step 1. Yep, we got it right. Step 2. Did she write? Whoa. What'd she do wrong?
She didn't even differentiate it.
Isn't that her differentiating it?
Oh, she had that. Oh.
She's just writing it out.
She's just saying, I'm going to differentiate cosine of x over x squared minus 6, which it is x squared minus 6 times the first derivative, the bottom, times the first derivative of the top, minus the top times the first derivative of the bottom over the bottom squared. Isn't this correct? Yep, it is. All right. All right. So find the derivatives. What's the first derivative of cosine?
The negative sign.
She must have made a mistake right there. So step 3, she didn't differentiate cosine correctly. Okay? Some of them, they will be correct. But you got to pick out where they made the mistake. Okay? All right. Then you'll have a section of how would you do this a different way? Okay? So it says, how would you do this by the power rule? And the power rule is like 6n to the 5th due to the derivative is 30n to the 4th. Okay, that's the power rule. So how would you do this using the power rule? Yep. And that would be, well, no, because then this would be the product rule. No, you can't. Why would it be C? Because straight up, using your words, because straight up, you can factor the top. X and X. Signs are opposite.
So it's negative 8 and a positive 5.
These cancel. And x plus 5 you would simplify it to and then do the product rule to that. Or the power rule to that. So you need to simplify it before you can do the power rule. So how would you rewrite that? You would divide. Are all of them going to be that simple? No. No. Now, you got to be careful because this one doesn't say the power rule. This one says the product rule. So how would we do this using the product rule? A would be the product rule. Okay? So read carefully. Okay? We good? Okay? This one again says the power rule. Whoop. Power rule. How would we do this using the power rule? Why is it not? Can't you just take this x times this x to make x squared? No. This would be the what rule? Quotient rule. This would be the quotient rule, so this is not possible. Jeez, you guys are on it.
No way, you are going to factor again. But it's not going to factor out. No, it's not. So it's not possible. You know, if there's one of them factors. Oh, yeah.
So what do you think?
It's not possible.
The other answers are power rules. So. Well,
I don't know. I don't remember the answer for this one. I'm almost thinking it's B, or because long division.
and then just say it's one.
No way. That is such cap.
What times x is x squared? Well, x is, and you get x squared minus 4x. Change the signs of the bottom row and then add. You get negative 5x plus 18. So then you go negative 5 to get negative 5x plus 20. change the signs in the bottom row and you get -2. So then you get this. So it's x minus 5 minus 2 over x minus 4. So you get that. You can do the power rule to that. You can do the power rule to that. No, that's a natural log. That would be, yeah.
You can't take the derivative of 2 and call it 0?
You can take the derivative of 2 and call it 0, but this,
And then 0 over whatever doesn't matter.
no, this would be the quotient rule. So I think it's not possible to do the power rule to this one. I don't think you can. I'm pretty sure you can't do the power rule to that because that's more complicated. Can you do this by using the power rule? Which one is it? It is most definitely A.
Okay, but how can you just like multiply that, but you can't multiply the other ones? Like, what is the difference?
That's a division problem. This is multiplication.
The one before that.
The cosine one?
Yeah, the cosine. This is cosine.
Because it's cosine. You can't multiply something on the outside with something on the inside.
But like all the other ones, you're doing like that's the front.
Oh. So, this is how you would simplify it before you do the power rule.
Like, then why can't we just do that for everyone instead of using?
It's because they're not all started the same.
I'm just genuinely wondering right now. Like, my little brain is being confused.
Oh, I'm sorry your little brain is being confused. Then we'll move on to what methods would you use to solve these? Would you use the chain rule and chain rule again? The product rule and product rule again? The product rule then the chain rule? Or the sum rule then the product rule? I don't know what the sum rule is. So it's not D. Okay.
Well, honestly, I don't even know at this point anymore because
Chain rule?
apparently you can multiply them.
This part you have to use the chain rule for. This, because we're multiplying together, we have to use the product rule. Could the product rule and chain rule be intertwined to do one first and then the other? So that would be C. Because you could do the chain rule first and the product rule maybe, but all right. If you see this, the top has to be the derivative of the top, you have to use what rule? To find the derivative of the top, the numerator, you have to use the chain rule. The inner and the outer.
I'll just look it up afterwards.
If we have 4x squared plus 7 to the 4th power, that's 4 times 4x squared plus 7 to the 3rd times the first derivative of the inside, which is 8x. That's the chain rule.
Yeah.
Okay? So if you have like the sine of 12x, it'd be the cosine of 12x times the first derivative of what's there, which is 12. So it's 12 cosine 12x. Okay? So, yeah. So you have to do the chain rule to that, but it's in a fraction, so you have to use the quotient rule, chain rule. What about that one?
Chain rule first.
And then after that,
The product rule.
what are we multiplying? I don't see any multiplying really. Well, I see multiplying, but not significant multiplying. So it's the chain rule and then chain rule again. Because this part, because it's really the sine of 2x squared plus 3x squared. So you do the chain rule to that and then the chain rule to this. So chain rule, chain rule. Yeah. How about this one?
Product rule.
I think product and product, because you do the product rule with these two, whatever you get from there, then you do the product rule with this. Product rule and product rule again. And then all of that will lead us to solving derivatives like this. Well, we're actually going to have to do this. So what would we do here? What would be our approach? Product rule and the chain rule. There you go. Good job. So the product rule is x times the first derivative of the ln of x squared plus the ln of x squared times the first derivative of x, right? So what's the first derivative of ln x squared? Well, that's the chain rule. Okay? So it's x times 1 over x squared times the first derivative of x squared, which is 2x, plus the ln of x squared times 1. So what's 2x over x? Well, 2x times x is 2x squared. Divided by x squared is just 2. So it's 2 plus the ln of x squared, which is that one. Okay? How about a logarithm one? Ew, I hate logarithm ones. You have to understand that with no base down there, you have to write the base 10 down there. Okay? So, I can't even remember logarithm. I need a note card for this. 1 over x ln of a, so ln of this stuff. So, it's the ln of 10. Yeah. So it's 1 over 1 minus x times the ln of 10 times the first derivative of this. So the first derivative finds the first derivative of 1 over 1 minus x. Yeah. Okay. So 1 over that is really x minus, or 1 minus x over the natural log of 10. So that's what this becomes. This, got to take the first derivative of that. Well, the first derivative of that, we could use a quotient rule, I guess. 1 minus x times 0, because the first derivative of 1 is 0, minus 1 times the first derivative of that, which is negative 1 over 1 minus x squared. So that gives me 1 over 1 minus x squared as the first derivative.
Hold on. Where'd your x go on the top?
Where'd my...
Because you're multiplying by 0. Okay, never mind.
Okay. So if we cancel, I get 1 over ln of 10, 1 minus x. Which is d. As long as my signs are correct, and I think they're correct. Which is that? Some of these are a little complicated today. You get into real calculus today. Okay, this one. Okay, so product rule, right? So it's 2x square root of x times the first derivative of the sine of x plus the sine of x times the first derivative of 2x square root of x, which is really 2x to the 3/2 power, correct? Because this is x to the 1/2 plus x to the 1 is 1/2, which is 3/2. Well, we're not taking the derivative of this. It just stays. So what's the first derivative of the sine of x? So it's 2x square root of x cosine of x plus Do the derivative of this. What's the derivative of that?
Whatever 2 times
3x to the 1/2 power, which is 3 square root of x, correct? Sine of x.
So that's A.
Yep.
Oh, that wasn't too bad. I thought it was more.
Nope.
Okay.
Last one. Last one. All right. What do we do?
There's a quotient
Yes.
rule and
Quotient rule and the chain rule. Way to go, Miles. So it's x cubed times the first derivative of this. Should we just go straight to the first derivative of this? What is the first derivative of cosecant? Well, you look at your note card because I don't remember it. I think it's, oh, see, I wouldn't have gotten that. So it's negative cosecant of 3x times a cotangent of 3x times what?
Times
3. Very good, because it's the first derivative of the inside. Minus cosecant of 3x times 3x squared all over, which is x to the 6. Yeah. All right. Now, let's factor out what can be factored out. I can factor out what? Negative cosecant of 3x. Is that the only thing I can factor out? No! What else can I factor out?
3?
Not 3. Oh, yeah, 3. 3 and what else? X squared. So then what is even left? Well, there's an x left here times this one, x cubed. X cubed and 3 is 3. So there's an x and then a negative and then a cosecant of 3x. What's left back here? Nothing, so it's a 1. Cotangent of 3x. Thank you. Negative right there.
You keep pointing anywhere.
I was pointing to this. There's our negative, which transfers to that. Oh, but. Okay, I screwed that up. Boom, boom. There you go. All right, we're good now, right? All right. X squared and x to the 6 leaves us with. So it should be negative 3 cosecant of 3x times x cotangent of 3x plus 1 all over x to the 4th. So it's D. Okay, so you have a lot of work to do today. Yeah, I did. 15 minutes almost right now, plus the whole second half of class, and you'll have a quiz to do. So guess what? How much did we do the other day on last Friday? No, you didn't do any.